接下来我们欢迎由 Amazon Web Service 的 Joe 为我们带来精彩讲题 The Evolution of JavaScript and the Public Cloud， 探讨 JavaScript 从过去到现在的发展，以及未来它在云端上的运用，以及它所扮演的角色。请各位掌声欢迎。
Better?
Yeah. Now you can hear me? Okay. I'm not going to speak Chinese again, though. That was it. Great. Well, thank you so much for having me here today. I'm Joe Ziegler. I originally, a little bit of my background here. Let's see if we can get this to work. There we go. That's me. So who's Joe? A couple of things. First of all, I am the startup business development manager for Asia Pacific for Amazon Web Services. So if any of you guys are in a startup or you're interested in working with startups, just let me know. I'll be here at the conference. In addition to that, I'm old, as you can tell from the gray hair. I come from the old days of Silicon Valley, way back in the 90s, when I think some of you guys were probably still in diapers. I'm an old-style programmer. I've done several startups myself. I work in kind of the startup realm. One of those startups you might have heard of, I'll just show you here a little bit. And I am a nerd. So I'm a geek, I'm a programmer. I work a lot with technology. Is anyone else here a nerd? Come on, be proud. Be proud. It's okay to be a nerd, okay? I usually program in C, C#, and now I do a lot of programming in Python. You'll see JavaScript's not really up there. I'm really bad with JavaScript. I'm going to be honest with you guys. But I did start using it a long time ago, and it's gone through a lot of different changes. So this is my background. These are the companies that I was at. So in particular, really interesting to this crowd, and I think why the sponsor or the organizers here invited me to speak, is I actually started at this little company called Netscape. Way back in the days. So we invented something called JavaScript. You guys heard of that? Yeah. That was a long time ago. I did a couple of other different startups. I went to a company called NetGravity, which then became a company called DoubleClick, which then got bought by a company called Google. You guys have heard that one? No? No one knows Google? This is going to be an interactive presentation. You have to play with me, or it'll be really boring. So that's what the internet looked like when I first started at it. So very static pages, right? That's Netscape Navigator. Actually, I think that's 2.1. Sad that I know that. But that's really what the internet looked like when I got kind of started way back kind of in the mid-90s. And this is what Amazon looked like at the time. This was our bookstore. So we've gone through a lot of different iterations, and we've changed quite a bit. But this was our first website at the time. So does anyone know that I don't work at a bookstore? Or do you think Amazon's a bookstore? Anyone? So I work for Amazon Web Services. So it's a different company from Amazon.com. It's actually, we do all these different web services. Maybe some of you guys have used our stuff. It came from Amazon. Basically what happened is we had to build this really big company, years and years of that big company. And to do that, we had to get some certain skills together. And those skills were like building really big cloud-based systems, big, secure, scalable architectures that would scale up and handle our customer base. So in about 2006, we actually started a new company called Amazon Web Services. And so anybody here can use Amazon Web Services. Any of you guys can just kick it off and use it right now. But you get the same kind of power as you would from a really big company. Right? So your little startup, or perhaps your class, or your own company, you can actually use the same types of services that companies like NASA use, or organizations like NASA, or like the NASDAQ, for example. So I'm going to talk about 3 different subjects, all related to JavaScript. I'll try not to bore you too much. Basically, I want to talk a little bit about how we kind of got here. So what's the history of JavaScript? Why are you guys sitting here? Why are you guys interested in it? Where did it all start? And then a little bit on where we are now. So some of the things that are going on in relevance to JavaScript and the cloud. And then I'll give you some hints on where these things are kind of going for us in the future. So a lot of my stuff is going to be very Amazon-centric just because that's the most experience I have. with the cloud, but there's lots of different service providers out there. It's not just specific to Amazon. A lot of these concepts and ideas are applicable across different providers. So where did it all start? So you guys want an academic lesson, right? So I did not start programming in the 70s. Thank you. I started in the 80s. But way back in the old days, before any of you guys were probably doing much, we had these big, powerful computers, these mainframes that are running, right? These big, usually they're IBM servers, these giant servers, and people would connect to these machines with dumb terminals. So just empty machines, IBM 3270 terminals, and these mainframes would do all the horsepower and all the crunching, and you would just basically submit to it, a batch process. You would do something like kick off a job, but your dumb terminal didn't do much, right? There wasn't much compute power on it. Then in the 1980s, what happened? We had the revolution of the PC market, right? So people started to get PCs. PCs had a lot of power. Microsoft Windows was everywhere. Macintoshes were taking off. And so we saw a big change that happened. So now, these dumb terminals are actually what we had thick clients. Right? So your machines could do a lot of processing, but they would still connect back to a server. So this is a client-server architecture that started to come out a lot in the 1980s. This is leading up to a story. I'm not doing it just to give you an academic a lesson. So then in the 90s, what's interesting is we started to get these browsers. And these browsers are actually kind of a step back. And you'll see there's a cycle that comes to computing. We keep going back and forth, back and forth, back and forth. So right in the 90s, it was very, very similar to what it was actually in the 60s and the 70s. But in this case, the servers were kind of these different types of machines, these web browsers or web servers, and the clients tended to be web browsers. And that's when the internet really started to go, right? So the internet started to take off, and suddenly we're in the same paradigm as we were in the 1960s. Right? All the computing power was sitting on these servers someplace, and your browsers, they didn't do much, right? They were very light. This came as a big surprise to a certain company. So at the time, complete surprise to Microsoft, right? They did not see this coming. They thought things were going to stay pretty much where it was in the 80s. They thought they were going to build Windows softwares. Those softwares had a very thick client to it, and it would get network and talk to other computers. Completely sideswiped when the internet came. Microsoft Windows 3.1 didn't even have a stack on it, right? It couldn't even talk to the internet. You had to download and install WinSock, for example. It didn't have a browser, right? And they saw this new company coming up called Netscape, and like, wait a minute, there's something going on here. We really missed the boat on this. I think my battery's dying. There we go. So this led to a couple of different strategies. So Netscape, where I was working at the time, they had this idea that you don't need to use Windows anymore. Right? They had this idea that we're back in this old paradigm that these web servers are serving off all the information, that maybe the operating system isn't that important anymore. And so the old concept between Netscape Navigator was that you could do everything on the server, and the browser would run anywhere. This did not make Microsoft very happy. Microsoft was in the business of selling software. And this led to a very famous period in the 90s in Silicon Valley. It was called the browser wars. So I survived the browser wars. I'm a veteran of the browser wars. So we'll do a little quiz here, okay? There are prizes. I have prizes. Does anyone, raise your hand, does anyone know the very first version of JavaScript? It was written, I'll give you some hints, it was written in Netscape, right? It was written in the 90s. You guys all know Brendon Eich, right? Who knows Brendon Eich? You know him personally? You've been to his house? Oh, okay. So what's the answer? Who knows the answer? Anyone raise their hand? Anybody have a guess how long the first version? You're an organizer. You can't get any prizes. Does anyone have any idea what the first version of JavaScript, how long it took? 2 weeks. Very, very close. Very close. Would you like some stickers or would you like a book? Don't throw it. There we go. Yeah. Very close. Not quite right. 10 days. 10 days. You guys are all here to talk about a computer language that took a guy 10 days to write. That might explain, you know, a few things like the globals and vars and stuff like that. And that's what Brendon and Eich looked like afterwards. He basically stayed up straight for 10 days, and that's not really him. I'm joking. He basically stayed up for 10 days to program and create JavaScript. Okay, bonus question. I have stickers or a book. Who knows what it was called? The very first version. Anyone? Come on, I got stickers. Look how cool it is. Anyone? I'll even be easy on you. There were 2 versions before JavaScript. Does anyone know either of the 2 names? Oh, come on. It's called Mocha. Yeah, it was called Mocha. Then after that, it was called LiveScript for like a month. And then Netscape did the worst thing it could possibly do. It said, hey, we license Java. We'll call it JavaScript. And so the confusion began. Right? It's these guys' fault. Where this is all kind of coming together was the reason that JavaScript existed is Netscape had a strategy. I'm not saying the strategy worked, but it had a strategy. What it wanted to do is it was the very first licensee of, at the time, Sun's Java. It was the very first one. And the idea was that we were going to take over the operating system market. People aren't going to buy software anymore, right? They're going to run Netscape browser. And they created JavaScript actually to entice, you ready for this? The guys that write Visual Basic. And that was the target audience for JavaScript. And then we thought, well, we'll get all the C programmers and the C++ guys. They're going to write everything in Java. So, really started in May 1995. The idea was that we're going to take over the whole space, the whole operating system space. We actually had server-side JavaScript way back then. So that was in the Netscape Enterprise Server 2.0. In my opinion, JavaScript had about 5 good years, right? Really until about 2000. And then what happened is we had all these different implementations came in, right? So the browser wars are going on. IE actually, it launches. Of course, what does IE do? They come up with what? Anyone know the name? JScript, right? Different implementation. We start to get all this fragmentation that actually happens around 2000. I call that the dark ages of JavaScript. So how did we get out of that space? How did it start to grow out? Surprisingly enough, this is actually very surprising to me. It actually all happened with ActiveX. So it's actually from IE. IE6 implemented a specific ActiveX object. That was this one right here, the XMLHttpRequest. That was the beginning of an idea that we could actually run really complex and sophisticated programs within the browser. And eventually, of course, that got ported over to JavaScript, right? And we started to be able to do asynchronous types of programming based on JavaScript. And then, of course, at the end of the day, yeah, it's IE7. Yeah, I'm right. Jesse James Garnett came up, and we started to get Ajax, right? And things could run asynchronously. And that was the beginning of kind of this rebirth, the renaissance of JavaScript. And then, perhaps in the future we're talking about Harmony, right? But JavaScript's still pretty fragmented. How many people here love to program for IE7? If you raise your hand, I'm going to take things away from you. You're not allowed to be happy. Take his laptop away, right? We actually have there's a company in Australia. It's called Kogan, and it's a retailer. They sell electronics. And if you go to their website in IE7, they charge you 15% extra. It's actually an IE7 tax, because they say it takes so much extra effort to build for IE7 that they're going to charge you more. So I'm really disappointed with the level of answers out of you guys. I'm sorry. I had a brand new Windows 8 laptop to give out, and nobody answered the question. No, I don't. So that's kind of how we got to where we are now, right? So we got JavaScript. It's quite fragmented. It was written in 10 days. You guys, I mean, you guys have mastered a language that guy only took 10 days to invent it, so it should be too hard. Very fragmented. And what you're going to see now is when we come to the enterprise space, we start focusing in on stuff on top of that JavaScript layer, right? So we're going to start focusing on Node.js. So where are we now? Well, things have changed a lot from the 90s when I started kind of programming. And the first thing, I'm going to say some controversial things here. The first thing I'm going to say is that for the most part, when we talk about cloud-based systems, we talk about the internet, your operating system is pretty much commoditized at this point. Nobody really cares what you're running, right? It's all running in the browser for the most part. So, you know, you're getting Windows, you got Mac, you got Chrome OS. Anyone running Ubuntu? I thought he would answer. Right? You got Linux, but we don't care, right? So everything's running within the browser, and on the back end, more and more things are running onto the cloud. And you're getting to that write once, run anywhere type world. We're seeing a convergence of this stuff coming together. Way back in the 90s, that was supposed to be Java. So, oh, I'll just write the Java program once and it runs anywhere. That never really happened. But we're seeing that more and more when we're talking about running it in these types of technologies, especially JavaScript. And people are buying less and less software, really. Now we're seeing more and more consumption of software. Consumption of services based on that software. Right? So even in the old world, you're getting stuff like Microsoft 365 that's running online. You're getting Google Docs, Google Apps, and all that. Everyone's constantly connected. You know, even right here, right now, you know, in my pocket, my phone's connected. It's talking up to some cloud-based servers, and we don't even worry about versions of stuff anymore. Right. So what version of Facebook are you using? You don't know. It's going to be continuous deployment, rapid software development. Even at Amazon, I think we tend to deploy code like once every 15 seconds. So this means that languages, you know, they have a different set of requirements than they used to have. And now we're getting all this cloud-based architecture. So in the old world, people were connecting to their on-premise infrastructure. And that on-premise infrastructure, it had some restrictions, right? You would connect to a computer somewhere that's running a program. In the new world, we've got this cloud-based infrastructure. And so that software is very different. You don't know when you connect to Facebook or use Google, you don't know where those servers are. You get redirected to a local server. You don't think of it in terms of software that you're installing on one single box. It's actually running across several different systems. So this is a different kind of software. This is software that has to have some different attributes. And what are some of those attributes that are important, especially important when we start talking about JavaScript? Everything's distributed by default. Nobody writes software to run on your laptop anymore. That's not, I say nobody, some people still do, right? But when we start talking about cloud-based applications, we're really talking about the stateless, highly scalable, expandable type software, horizontally scaling out. What do I mean by horizontally scaling out? We can just add computers to it, and the more computers we add to it, the more compute resources that we add to it, the more people we can serve. And then we get this elasticity. So the elasticity of the cloud. That means I can pull resources from the cloud and use as much as I want and then give it back to the cloud. The utility type computing. And everything's highly available. You don't get to have downtime anymore. Everything has to be available all the time. You know, if you went to Google.com and you got a 404, I think that would be the end of the earth. People would be like out screaming, "My God, Google's down! It's over!" No, you got to be up all the time. And it's global and ubiquitous. So software is available to everybody anywhere in the world. And I talked about kind of it's continuously deployed. So what does that mean when I talk about JavaScript? Well, we really like JavaScript. We like it for several reasons. At Amazon, we want software that's going to be easy to write, and it has to scale out massively. It has to handle lots and lots of requests. It's event-based architectures. It needs to be able to handle as many requests as it can, lots of different users coming in. We like software like that. So at AWS, Amazon Web Services, we actually build software on top of AWS. AWS uses AWS to build AWS. It's like Inception, right? It just keeps going on. It's like Lisp. So of course we like that, right? So server-side JS is very exciting to us. And I think you'll see that a lot of the different providers, a lot of the cloud providers are going to have Node.js implementations. And Node.js is really interesting. It has some good properties when we talk about interaction with the cloud, especially when we talk about those types of applications that I spoke about just a second ago, the ones that scale out, they're horizontally scalable, and you can consume all these different web services. So first of all, Node.js is quite fast. It actually runs really well on the web server. I have different clients who are implemented in different technologies. We'll call it PHP. That we're able to, switch over to Node.js and see massive performance improvements. And that's because coming from the JavaScript world, from day one, it was event-driven. It was based upon the interactions of the browsers. And that really gives Node.js a big advantage in this space. Because if you think about it, these other languages that we talk about, they've been adapted to run on web servers. They've been adapted to run on the web, right? They have frameworks. They weren't originally conceived to run in this different environment. So that means JavaScript actually has a very unique advantage in this space. It is very fast. It has non-blocking I/O, for example, right? For web apps, it's really good, especially mobile gaming apps. We have customers who are using Node.js very successfully on the back end. They're able to spin up a lot of servers. They might keep some of the legacy code, the PHP code, but the back end on the web server will talk to Node.js. And the other great thing about it is it's really easy for people who are already using JavaScript. It's an easy transition to bring people in who are used to developing stuff in the browser. You can now actually write enterprise-level cloud-based software using Node.js. So we invest quite a bit into Node.js. Does anyone here use Node.js? Okay, give them all stickers. There's like 40 people. Faster, faster. No, I'm just joking. If you use Node.js, you can definitely get some stickers. I'll have stickers for you. Who programs in JavaScript but doesn't do Node.js at all? It's okay, don't be shy. Why? Just don't like it? I'll ask you later. So what's really cool with it is just instantaneously you get the ability to run really low latency systems. The other thing about it too is it's single threaded. And why is that important to us? Well, as it turns out, when you're developing software now, it's a lot easier for cloud-based software to have something that scales out with lots of little servers. So if you've ever written enterprise software, like I used to work quite heavily in C and C#, and I would, if I want to take advantage of a really big monolithic machine, something that has a lot of compute power, and take advantage of all the different cores, I'd write some very complex code. I'd write semaphores, and I had to make sure that I could communicate, make sure that everything's multi-threaded, and I'm actually a really bad programmer, and so I would always get memory faults and break everything. By being single-threaded, we get rid of all that complexity, and you can scale that out on the cloud really well, because in the cloud, of course, you can spin up 1,000 servers instantly to run across your application. So why do you care? Because this is what you want to be able to do with Node.js. This is how you develop cloud-based software. Well, now there's a diagram, people wake up a little bit, right? This is a very standard architectural diagram we do at Amazon all the time. Very common thing, right? You've got a load balancer that's sitting there, and you got people doing different requests on the web, back and forth, back and forth. The key concept is you want to be able to write software that does that. So you want to be able to write software that when the server spins up, it bootstraps, it connects into the pool, and is now able to serve requests. And that's something that Node.js can do very well and very fast. It's also important so that when you're not serving requests, you can go back to that. So you have to go between the two, right? You need to be able to add servers to your system. Does any of you guys know Pinterest? Who uses Pinterest? Anyone? I don't use Pinterest. But it's a really big customer of ours, right? They do this very, very well on the back end. So they've got it so at peak, when people are really using Pinterest during the day, they consume about $79 of our services. That's their whole infrastructure. And then at the lowest end, it drops down to about $17. And that's because they've got the ability to scale out like that. That's why. That's why it's important to be able to use Node.js in the back end. Another good example of a customer who's done that successfully is a startup called Animoto. And what they did is they got a little app. It just takes your photographs and it puts music to it and makes it kind of into a video. It's pretty cool. But what they found out was that nobody was using their app. So what they did is they hooked it into Facebook. And in a very highly scalable fashion, what happened is they hear about here they had maybe, let's say, about 50 different servers serving off web servers on the back end. When everyone started to connect into it, it jumped up to about 5,000 servers. And this is a period of a couple of days. So this is what we mean about horizontally scalable and the elasticity of the cloud. And then the cool thing too is, kind of dropped off a little bit. People stopped using it. Maybe the buzz wore off a little bit. They were able to return that back up into the cloud. Ah, my battery's dying. Get closer. So what can you do with Node.js if you're dealing with our type of infrastructure? Well, you can actually do everything. So you can actually program the entire range of AWS services purely through Node.js. Everything inside of the Amazon's cloud infrastructure is an SDK or an API or a web service. So without learning any type of new code whatsoever, you guys can actually program across our entire range of services. And so we've got the SDK if you guys are interested. You can go there to SDK for Node.js. Oh, there's me. Okay, that's pretty cool. It's kind of unnerving. You can actually see the Getting Started guide, the developer guides, everything on there. And so what can you control with it? So if you guys are interested in getting into this kind of technology, if you're interested in using the cloud, you don't want to learn any kind of new language, you can use Node.js across our entire infrastructure. So you can access storage services, for example. We've got something called Simple Storage Service, or S3. Does anyone use Dropbox? You get some stickers, because you're the first hand up. Where's my sticker? You have one job to do, mate. One job. My God. with the red lanyard. Okay. Dropbox actually runs on something called Simple Storage Service in the back end of our system. So Dropbox is 100% on AWS. You can control search functions. You can do big data. If you guys are interested in processing massive amounts of data, you can do that from Node.js by reaching through our API and using something we call Elastic MapReduce. And you can crunch all these big data numbers using Hadoop without learning any type of new technology whatsoever. Relational database services. You can create a database with Node.js. You can create an Oracle database or SQL Server database or a MySQL database with Node.js. So everything within the Amazon Web Services universe can be initiated on the back end through that language. And here's kind of a list of everything that you can do with it. And I'm sure it's true also if you're interested in other providers, they also can have sets of different APIs that you can reach out to. But the really cool thing about Amazon, what I like about it is everything we've got, you can do through JavaScript. So you don't have to use a web UI. You can automate stuff. You can build really complex applications without learning any types of new technologies. We have NoSQL database, for example, that scales up in an unlimited fashion. You can put as much data in it as you want. It'll never slow down. You tell us how fast you want it to run, actually. You can actually set up your DNS services with Route 53 through JavaScript. What else? We have a content delivery network that you can control. All of that stuff comes through and it works with Node.js. There's lots of good docs and developer guides online if you're interested in getting involved with the technology. Also, what's our credits we're giving out to everyone? 50? So everyone has $50 worth of credits. If you're interested in playing around with this technology, $50 in credits will actually go quite a long way. 50 US dollars actually goes quite a long way. And we've got some really good community up there. So we've got discussion forums, we've got GitHub repositories that you guys can download with different types of code and examples. It's really interesting things. But let's say you don't want to learn any of this stuff. Maybe you're a lazy programmer. Like me. I'm the laziest programmer in the world. I gotta be honest with you guys. Most of my programming background was mastering copy and paste. Right? I have a degree in copy and paste. I'm gonna be honest with you guys. I don't think I've ever written a line of code. You know, oh, that looks good, copy paste. If you don't want to learn any of this stuff, if you don't care about this stuff, but you want to write like a really big, scalable, cool web-based application, you want to use Node.js, or really, lots of different kinds of technology. It doesn't have to just be Node.js. We've got this really cool service. It's called Elastic Beanstalk. And I actually tell all the startups that this is a great place to get started if you're interested in using web services. It's a container. So you can actually write any kind of Node.js application. You have to follow some kind of specifications. And you can deploy this to Elastic Beanstalk. And I'm just going to talk about a little bit about what Elastic Beanstalk is, because it is one of my favorite applications. And the cool thing about Elastic Beanstalk is there's no additional charge to use it. So it's charged the same as if you use Amazon Web Services. You're not giving up anything for it. What that's going to allow you to do is you can create your Node.js application, and you can inject it within the AWS infrastructure. And we do kind of all the heavy lifting for you. So if you don't like to install web servers, if you don't want to manage databases, if you just want to write your application, we can do all this stuff for you. So we'll actually deploy it using Amazon Linux in the background. We'll have the containers all set up for you, the interpreters, all the basic stuff, and you guys can just write. You can write your application and not worry about the infrastructure. And the way it works is not, so this is kind of like inside your compute instance. We do all that work for you, and then your Node.js app sits on the top. In addition to that, we'll take care of all the Amazon Web Service stuff. So if you don't want to learn the API, if you're lazy like me, if you program from copy and paste, we will actually handle all the different components for you. So it'll set up like a load balancer on the front end. It'll set up all the different types of servers. It'll set up auto scaling, so you can tell us, for example, hey, when my application is using 80% of the CPU, I want you to add 2 more servers, 3 more servers. And when it's doing less, I want you to scale it down, like Pinterest does. Come on, clicker. So I'll set up all these different compute instances for you, and then it'll actually bring that all together. And then if you want to, it'll even set up a database for you if you want to use like a MySQL database on the back end. And the cool thing too is it's a great way to get started, because what you can do is after you create your application, you deploy it into Node.js, you can go underneath and you can see how we set everything up. So it's not covered up. You can kind of pull over the coverage, you can look down and you can see how everything works. It's a great way to get started fast because it's best practices. You'll see how we set up the security groups. You'll see how we set up the auto scaling. And there's some neat things too, like we'll do the versioning for you, and I'm going to do a demo on this later. We do like all the versioning for you, so you can actually write an app, you can deploy 1.1, 1.2 to your production environment, to your test environment, and you don't have to worry about managing that process. You don't have to worry about how many servers are running. So it's a really great way to get started if you want to run some kind of massive kind of web-facing application. The other cool thing that it does is if you're ever trying to do something, you're debugging like a live application. So if you've got like an environment where maybe you've got 10 or 15 web servers that are running and you're trying to track down a bug and you don't know where the user is and you're going through these web server logs, it's a pain to do that. All that stuff will get uploaded into our storage system, our simple storage service, all those different web server logs. And so it's a lot easier to do debugging. You can find, it's all in one place. The really cool thing you can do too is if you guys like, that's unnerving. If you guys like big data, you can actually do processing of big data on these types of files later using Elastic MapReduce or using different tools. So I'm not going to do the demo today. I'll have a demo tomorrow at 3:40. I'll actually bring up Beanstalk. I will deploy a live application, and you guys can see that. If you're interested in that, you can come tomorrow. We're also going to give out additional $25 of credits for that workshop. Between the $50 and the $25 of credits, you can run an application for quite a while on top of us. Okay, so that's kind of where we are now. We've got these cloud-based systems. We've got Node.js. We've got a whole bunch of programmers now who don't have to install web servers and install databases, and they can build these cloud-based architectures. I'm going to give you a little insight on where we're kind of going within kind of Amazon, where we see these things going with relation to JavaScript. So we've got this picture. This is outside with my colleagues. They have this picture here, and this is a very typical kind of web serving architecture. So has anyone built like highly scalable web apps? You guys do that? Anyone? No? Yes? So this is a very typical architecture, all right? So how many tiers do we have in this? You guys who've got computer science degrees, right? How many tiers do we have on this? Does anyone have the answer? Anyone? Take a guess. I'll give you a hint. It's an integer. You are correct. He gets a book. Yeah. Yep. So this is a typical 3-tier architecture, right? So you've got databases in the back end. You've got application servers here. You got web servers here. And then somewhere this guy's coming along. And it has to go through all these different tiers in order to do the business logic. And at Amazon, we're going to charge you to use these compute services here and these compute services here. And then we've got these highly available services that exist out in the web that you get charged to use on like a per usage base. But these are compute services here. So a different way to look at that architecture is something like this, although I'm blocking it. There. Those are my databases. So you know that would be a very typical architecture, right? The same kind of like n-tiered, 3-tiered architecture. My browser's going through, it's going through some kind of load balancer. These are compute instances, you know, essentially they're virtual machines, right, running some kind of operating system. Maybe there's an app server on the back end that's processing some business logic. And a two-tiered architecture, maybe that's kind of combined together. We've got some storage services and some database services. This is, you know, it's fairly complex, right? There's lots of room for problems. You can build something highly scalable this way. You can build something that's, you know, highly available, but, you know, you have to build it up and you have to take into account many different things. And that's why you get kind of this type of architecture, right? We have multiple versions of these guys sitting around. That way, if one of these guys dies or I've got a bug in it, right, the rest of them pick up the slack. This makes it highly available. And they scale out and they scale out. The Amazon stuff, like the simple storage service, which is right here, or S3, that's already highly available. You don't have to worry about it. You don't have to build anything. You can talk to it. It's always going to be able to handle it. It handles hundreds of thousands of requests per second. You don't have to worry about that stuff. But when you build your application, you got to worry about this stuff. What if we take this idea here? Remember, this is kind of where we are right now, back again, where it gets looped back in. What if we take this idea where the browsers are talking to web servers and we get rid of the web servers? What if in the future, and I'm not making any promises, what if in the future you had the ability to call out to these cloud services on the client-side JavaScript? Well, think about what you would gain with that. What if your client-side JavaScript could talk out to a highly available relational database and not a web server? What if it could talk out directly to storage services? Well, now your architecture is a lot more simple, isn't it? You don't have all these different web servers you have to keep up or application servers. So this is where kind of the future's going, where we see JavaScript going, is what if you had a set of libraries, you know, kind of like JQuery libraries, that could talk directly to highly available, highly scalable web services, and you don't have to worry about the application on the back end anymore. It's an interesting concept. It's gonna change quite a few things. Okay. So that's going from an n-tiered architecture. I call it a no-tiered architecture. Your web browser consuming web services directly through JavaScript. And you can't steal that, I've registered it. This is my idea. So if anyone makes money on that, you can send me an email, I want 10%. Okay, so a few administrative stuff, little items here, and then I think I'll let you guys get to your conference. We do have a booth. It's up in the back and to the left over there. We've got my colleagues are here that represent the team. We've got solution architects. If you guys have technical questions, if you want to use web services, if you've got an application you're writing or you're working with us, we'll be happy to help you out. We've got our account managers here. We've got a survey that you can come and fill out and get your credits. We have lots of stickers. Even if you don't use Node.js, you can have some stickers. Tomorrow I've got the demo. If you guys want to see what it's like to bring up a really highly scalable application, I will bring up a Node.js application, and then I will probably do something cool with it, like do like a denial of service attack and see what happens with it and stuff like that. So, and that's all I've got for you guys. Here is my Twitter handle. If you're interested in following me, I usually tweet out stuff that's relevant to AWS and relevant to startups. But I'll be here for the rest of the day if you guys need anything. So I appreciate your time. I hope you have a really good conference. And thank you very much. We have time. We have time if anyone has any questions. Just for fun, who wants some stickers? Raise your hand. Okay, start running. Oh, come on. Does anyone have any questions? I'm happy to answer. There we go. Run, go give him stickers. There's Sticker Boy. We hired him full time just to give out stickers. He has a degree in stickerology. Does anyone have any questions? I'm happy to answer any questions if anyone's got anything. Did I used to work with Brendon Eich? The answer is yes. Back then, he looked a lot more like Elvis. No? Thank you.
好，那我们谢谢 Joe 给我们带来的分享。